Is FRQ part 4. And for the first part A, it asks us to draw a free body diagram of the system. And so we have a force diagonally acting, and that is going to be our Fn. And then we have a force acting straight down, which is going to be our Fg, and which is also smaller than our Fn. Next, starting for part B, we know that sigma F y is equal to 0. So we know that Fny minus Fg is equal to 0. So we can say Fn cosine theta is equal to mg. And we know due to the diagram that cosine theta, which is adjacent over hypotenuse, is the same thing as d over r. And so we're going to go ahead and substitute Fn cosine theta for Fn d over r is equal to mg. And then we're just going to isolate for Fn. So we'll get Fn is equal to mgr over d. And that is our answer for part B. All right, so for part C, we're just going to start with Fc is equal to Fnx. And so we can make take that and put Fc is now equal to Fn sine theta, which is just Fnx. And now we can take Fc is equal to mg over cosine theta, which is what we found earlier. Simply taking the d over r and replacing it back with the theta, cosine theta. And so we're also going to have to multiply that by sine theta. And so after that, we can cancel out, or we can substitute Fc. So we'll have mv squared over r is equal to mg tan theta, as sine over cosine is tangent. And we can cancel out the masses. And we know that tangent is just equal to opposite over adjacent. So we'll just have r over d, or little r over d. And we also know that r squared is equal to d squared plus r squared. So due to Pythagoras theorem, so we can just use algebra and have r squared, little r squared is equal to big R squared minus d squared. Because we're going to use this. And so now back to our original equation. We're just going to move this to the left. And here we're just going to multiply the r value to the right. So we're going to have v squared is equal to gr tan theta. And now we're just going to replace tan with what we just found as r over d. So we'll have v squared is equal to gr squared over d. And then from here, we're going to get rid of the exponent. So we'll have v is equal to the square root of gr squared over d. And now we're just going to substitute r squared for what we found on the right. So we'll have v is equal to the square root of g big R squared minus d squared all over d. And as long as d is equal to y, we can substitute d with y, and we'll have v is equal to the square root of g r squared minus y squared over y. And that is our answer for part C. All right, now for part D, we're just going to start with V. With V is equal to R omega. And so because of this, we also know that V squared is equal to R squared omega squared. As we could just square both sides and it'd be equal to each other. And so next we're just going to have V squared is equal to R omega, R squared omega squared. And we're just going to substitute what we found earlier. So for V squared, we have G R squared over D is equal to big R squared minus D squared times omega squared. And this is substituting what we found before once again in part C. So next, we're just going to take R is equal to D plus Y and say that D is equal to R minus Y. And now from using that, we're going to substitute it in later. So first things first, I'm going to take G R squared and I'm going to substitute big R squared minus D squared and put that over D is equal to R squared minus D squared times omega squared so that we can cancel those two out. And then from there, we're just going to have G over D is equal to omega squared, which is just omega is equal to the square root of G over D. And now we're going to use what we just found earlier. D is equal to R minus Y. And we're going to substitute that in for D. So we're going to have omega is equal to the square root of G over R minus Y. And that is our answer for part D. So for part E now, we know that omega is equal to the square root of G over D. And it wants us to find that omega minimum is equal to the square root of G times R over R. And so to find the minimum omega value, we would simply take D to be the same as R, the same value as R. So we'll have omega is equal to the square root of G over R. And to get to the function that is given in the problem, we can just simply multiply by the square root of R over the square root of R, which is just multiplying by 1. And we'll have omega is equal to the square root of G, square root of G times the square root of R over the square root of R times square root of R. And so square root of R times square root of R is just R, so we'll have R on the bottom, and then square root of G times square root of R is just the square root of G times R. And so that's how we find omega minimum. Now for part F, we know that R is equal to 0.2. Y is equal to R over 2, which means Y is equal to 0.1, as that's just 0.2 divided by 2. And then we also know that omega is equal to the square root of G over R minus Y, as we proved in part D. And so we could just plug in the values that we have just solved for here, or were given. And so we have omega is equal to the square root of 9.8 over 0.2 minus 0.1. And so that would give us approximately 9.9 rads per second. And so to take 9.9 rads per second and to make it into revs per minute, we just have to take 60 seconds over 1 minute times 1 rev over 2 pi, and multiply that times our value of 9.9. So when we plug this into the calculator, we get approximately 94.5 revs per minute. And so that would be our answer for part F. And so now moving on to part G, I'm going to start with omega is equal to 2 pi over the period, which is really just theta over t. And we're just going to move this around. So we're going to have t is equal to 2 pi over omega. And so we can just substitute omega with what we found before. So we're going to have t is equal to 2 pi over the square root of g over d, which we found in previous parts. And so we're going to have t is equal to 2 pi times the square root of d over g. So that's for the period. And now for part H, we're just going to have f of c. Fc is equal to mv squared over r to start it off. And so we know v squared is the same as omega squared times r squared, as we saw for that earlier. So we're just going to have fc is equal to m omega squared r squared over r, which can be boiled down to, once we cancel out these r's, m omega squared r. And so from here, we're going to take m omega squared times r and set that equal to fn x, which is the same thing as fn sine theta. And so we're going to have m omega squared times r sine theta, which we've solved for before. And as we know, that little r value is the same as r sine theta due to this. And so we could set this all equal to mg over cosine theta times sine theta, which we found in a previous part. And we could just cancel out our sine thetas. And we can also cancel out our masses. So we'll have omega squared times r is equal to g over cosine theta. And so from here, we can just multiply r over. So we'll have w squared is equal to g r over cosine theta. And we'll just square root this. We'll have omega is equal to the square root of g r over cosine theta. And that will be our answer for part H and the final part of FRQ4.